All right, the last problem. The last problem. Woo! Ugh. Oh, my voice is shot. It was shot even before I started this, I think. Oh, God. What was I saying? The last problem! All right. We want Gandalf to be able to authenticate the messages he sent out. That is, he can pad them with some extra information so that people can be quite positive it was him who sent them out and not somebody else, and that they weren't tampered with and so on. And how are we going to do this? We're just going to take RSA, like we were using in the not last problem, the penultimate problem, and we're going to turn it on its head. How do we turn it on its head? We're just going to swap the roles of everything. What we were calling encryption, now we're going to call authentication. And what we were calling decryption, now we're going to call authentication. What I mean is, what we were calling encryption, that's now what Gandalf is going to do in private to make his messages clearly his, and what we were calling decryption, that's what anybody can do now to see whether the message is in fact from Gandalf. So, we have N and D and E just like before, where N is a product of two distinct primes, P and Q. Everything, all the same setup as RSA in terms of the values we have and the relations they're supposed to have. But now, only Gandalf will know how to encrypt, and everybody will know how to decrypt. So, everybody knows N and D. D and E are symmetric, so it's no real difference. But everybody knows N and D. Only Gandalf knows E. And if he likes, it's not super important. And P and Q, once you have P and Q and one of E and D, you can figure out the other, P and Q and N. Anyway, only Gandalf knows this secret thing, E. And, when Gandalf wants to send out a message, Gandalf doesn't just send M, Gandalf sends M and what would normally be the encryption, which anyone can do in public key cryptography under our familiar protocol. Now only Gandalf can do it. Gandalf sends M and its encryption. That's M to the E mod N. And others verify messages. So suppose they received M and what I'll call M prime by checking that if they decrypt M prime by our usual protocol, so M prime to the D mod N, they will in fact get the message that was sent. M prime to the D mod M, N is to be M. Actually, you don't have to send out both M and M prime. You could just send out M prime and let them rediscover M from that. Now, why does this work? Well, this works basically for the same reason that RSA works, or you could use any public key cryptography system in the place of RSA here, basically, and it would work for the same reason that public key cryptography system works. Your proof of the correctness of decryption and the difficulty of decryption for someone without the private information would just amount to the proof of the correctness of the verification here and the difficulty of the ability to forge messages. I shouldn't say difficulty of the ability. The difficulty of forging messages for excuse me, for anyone who doesn't have access to the private information. It's just all the same principles that underlie your public key cryptography. You just rename the roles, and those principles become the principles you would want here. I should say, it's actually rather easy to forge a gibberish message. You just send out whatever random nonsense M prime you want, and the corresponding M, you just send out M prime to the D mod N as your M. Now you've sent out some gibberish message and made it look like it comes from Gandalf, I suppose. But we could add some safeguard against that, right? We could say Gandalf's message always has to start with some particular string. The M always is padded out to start with some particular string or something. And then it's no longer the case that people could send out some random gibberish message and have it look like Gandalf meant to send out random gibberish. So, but that's the general idea. That the thing I outlined before is all you needed for full credit for this problem. I believe you don't have to be super robust. Just the basic idea of sending out messages in this sort of inverted way from what you would do with RSA, just inverting the roles. I keep saying RSA because that's the only public key cryptography system you know, but really the idea would work with any public key cryptography system. It's sort of more abstract than caring about the details of RSA in particular. Any public key cryptography system, we could invert it in this way. All right.